Just quickly refresh our memories on the hyperbola, the standard form, and how the Q and the A affects our graph. All right, there is our hyperbola. Y is equal to A over X plus Q, and that's how we identify that it's an hyperbola, right? Our X is part of our denominator. And over here, you were introduced with some new terminology, the asymptote. All right, I'm quickly going to make my A. Let me just make my A1 for now. And let's start by changing to the Q. So our Q value is going to move our graph up and down. If my Q is positive 1, then it means that the graph moved 1 unit up. And then our asymptote would be over there. That line, y is equal to 1, is our horizontal asymptote, and our vertical asymptote is the line where x is equal to 0. Those are the two lines that our graph is not going to cut, and we'll talk about why when we get to our questions. All right, if I move it down, if my Q is by negative 1, then it means that my horizontal asymptote is going to be by negative 1. And if I keep moving it down, same story. So let me just quickly take it back to 0. So now it didn't move up or down, and my asymptote is just there, the line y is equal to 0. Let's quickly change to the A. So right now my A value is 1. Notice as I make my A value bigger, that it's as if how would we describe that? It's as if the curves move further away from each other, or they're less pointy maybe. And there my A values are positive. There it's a positive 5. And our curve is in quadrant 1 and quadrant 3. And then as our A value is negative, our curve will be in quadrant 2 and quadrant 4. And this is knowledge that you need to have that will make your life a lot easier. Okay, let's go ahead and do some questions. Let's do 4 different questions on the hyperbola. We're going to draw, we're going to find the equation of it, and then we're going to do some interpreting questions. So for the first one, it says, draw a rough sketch of the following. Now, we must be able to identify that as a hyperbola because our x is in the denominator there. And then they give us a little bit of information. They say that our A value is bigger than 0, so that means our A value will be positive. Whoops. Our A value will be positive. That's better. And then it gives us that our Q value is smaller than 0. So our Q value is a negative. And we need to know how to interpret that and know what to do. So there's my set of axes with my y-axis. There's my x-axis. Okay. What does the Q value mean? If our Q value is a negative, it means that our whole graph moved down. So our Q value also gives us the asymptote. So it means that our asymptote will be somewhere where y is a negative. So I'm going to put my asymptote in first. And then when my A value is positive, it means that my curve will be there and there. So I'm quickly going to go put them in. So it will be somewhere there and somewhere there. There's a rough sketch of my hyperbola where my A value is bigger than 0 and my Q is smaller than 0. Second question. Sketch the graph of y is equal to, let me copy it over, y is equal to 6 over x and take away 1. All right, there we can see that our A value is positive. Our A value is positive 6. And there we can see that our Q value is negative 1. Remember, the Q value gives us our asymptote. It moved 1 down. So we can immediately go put that in. There is our asymptote. Please use your ruler. And that is the line where y is equal to minus 1. So I put my asymptote in, done. Now we need to plot some points. We can't just eyeball it and decide where we think the curve is going to be. We are going to have to go calculate it. Now think about it with me. If this whole groove, not the groove, the whole graph moved down by 1 unit. Surely there must be an x-intercept now, because think about it. Before it moved down, our curve will be there. And now if the whole groove why do I keep saying groove? If the whole graph moves one down, surely it must cut the x-axis somewhere. So now the question to you is, how do we find the x-intercept of any of our graphs? We have to go make our y 0. So with the hyperbola, we are confronted with doing some equations with fractions. Let's go plug in our y 0. All right, so far so good. I'm going to take that 1 over. This is just equation knowledge. And from there, it doesn't matter how you choose to solve that, great teens, but I am going to get rid of the fraction. I'm just going to say I'm going to multiply by x on the right, and whatever I do on the right, I must just do on the left. So when that happens, those two will cancel out, and I'm left with that, and 1 times x is just x. So I get that my x is equal to 6. Let's think about what we just calculated. We just calculated the x-intercept, because when we made our y 0, we got an x of 6. So there is our x-intercept. All right, perfect. Now, that's not enough. We're going to have to plot some more points. So I'm just going to use a table. I'm going to choose some strategic points for x, and then it's going to give me my y's. Let's just quickly see if this Cartesian plane has enough. 1, 2, 3, 4, 5, 6. Yeah, I think we need to change that. Let's make one block. Let's make one block 2 units. So if -2 is there, then -1 is there. Do you see what I'm doing? Because my grid doesn't allow for that 6 there, I'm just making this. That is where my y is equal to -1, and that will be my -2. So I'm just changing the units of the blocks. All right, now what do I mean when I say that we are going to choose strategic points for x? Well, since my 6 is being divided by x, and I want to plug values into the place of x to see what output y values I get so that I can plot some points, I am going to choose x values that is easily dividable by 6. Now, it doesn't really matter what you choose, but I'm just going to avoid working with fractions because they're just harder to plot. But it's not the end of the world. It can be done. I am going to choose where my x is equal to 1. No, maybe 2. And I'm going to choose where x is 3, and I'm going to choose where x is 6, because all of those numbers goes nicely into 6. But then what you need to remember, grade 10s, is if I just choose positive x values, I'm only going to get this curve that I can plot. But what about this curve? I need to substitute some negative x values into my equation in order to get points that will plot the graph for me in that quadrant, in the third quadrant. So let's go substitute. -2, -3, and -6. All right, let's go ahead and do that. So we're going to get 6 more coordinates that we're going to plot. Our x-intercept is by 6, so that would be 2, 4, 6. So we know that it will cut the x-axis there. We already calculated that, right? Okay, let's go plot a few more points. If I substitute x as 2, I'm just going to draw it over there, or calculate it over there. That, and then I need to take away 1. 6 divided by 2 is 3, and if I take 1 away, that will be 2. So there's another point that we can plot. Then my y, what is my y if my x is 3? And that's 2 minus 1 is 1. There we go. And then when my x is 6, 6 divided by 6, oh, we already have that. We already have that, so we don't even have to go do that again. And where are we now? By the negative numbers. All right, so when my x is -2, let's see what that will get us. 6 divided by -2 is -3, and if I take away 1 more, that will give me -4. Be careful with these substitutions. And then when my x is -3, 6 divided by -3 is -2, and I take away 1 more, that will give me -3. And last one, if my x is -6, that will give me -1, take 1 more away, and that will be -2. So we, grade 10, just created a bunch of points that we can go plot. So there is my point where my x is 2, my y is 2. So I can go plot that. Where my x is 2, my y is 2. It's that point over there. And then when my x is 3, my y is 1. Where my x is 3, my y is 1. Remember, I used one block as 2 units. I mustn't forget that. That one we already plotted. And then when my x is negative 2, my y is negative 4. When my x is negative 2, my y is negative 4. There we go. And then when my x is negative 3, my y is negative 3. And then when my x is negative 6, 2, 4, 6, that one is by negative 2. There we go. So now we've got some points plotted that we can go and connect to draw our curves. There is that one in my first quadrant. It goes closer to the asymptote, but it will never cut that. And then this one over here, it goes close to the asymptote, but it will never cut. Close to the asymptote, but it will never cut. And I put my arrows. And then it's important to always go show your points of intersection. There, that point is by 6 and 0. And there you go. Now with question 2, they ask us a bunch of questions about this graph. Let's see. Write down the equation of the asymptote or asymptotes. There's 2 for a hyperbola. And please note, students normally go right, oh, well, the asymptote is by negative 1. They're not going to give you your mark there. You need to write down the equation of it. Okay. So there is our horizontal asymptote. That is the equation where y is equal to negative 1. And then our vertical asymptote is where x is equal to 0. It's this one over here. That is our vertical asymptote. Our x can't be 0. Why? If we look at this x can't be 0 because if it is, the denominator in a fraction is equal to 0, which will make it undefined. Then the graph won't exist. This is where your fraction knowledge comes in. So that is why that is our asymptote. Let's look at the next question. It says that we need to give both axes of symmetry. I find that this is such a good one that students often get wrong. So let's make sure that you are not one of those. There are 2 axes of symmetry for any hyperbola. I'm going to go draw it in for this one. What color shall I use? Let's use something bright that we can see. So my one line of symmetry would be this one over here. You know what line of symmetry means? It's like a mirror image where the one side is exactly like the other. My one line of symmetry would be there, and my other line of symmetry would be somewhere over there. But there's 2 things that you need to know about these lines of symmetry. The first thing is that they both go through the point where the asymptotes meet. So they both go through that point. My x is 0. And my y is by negative 1. You can't see that there, so I'm going to try and do better. So what is the point where the 2 asymptotes meet? The point where the 2 asymptotes meet, that one over there, is the point where x is 0 and my y is minus 1. So both the lines of symmetry will go through that line. The second thing that you need to know about the lines of symmetry is that both of them has got a gradient of 1. So this line will have a gradient of 1. So for your mx plus c, your m will just be 1, x plus c. And for the other line, this line will also have a gradient of 1, but in this case, just a negative 1. So negative 1, x plus c. That is knowledge that could make your life a lot easier. So positive gradient of 1, a negative gradient of 1. Why is that really helpful? Because then we only have that c value, that y-intercept, that we can go read off the graph or calculate if we don't have it. So in other words, for the 2 axis of symmetry, the one axis of symmetry would be 1 is equal to mx, positive gradient of 1, and then minus 1. Where did I get that? That is the y-intercept of the straight line. that line will cut by -1 because it will go through the point where the two asymptotes meet. Then the second axis of symmetry will have an equation of y is equal to -1. So we don't have to write the ones, hey? They're imaginary, but they're there. -1, and it will cut in the same place. It will also go through that point where my y-intercept is -1. So this is where your linear, your straight line graph knowledge is being used as part of your hyperbola. They like asking these questions. I've literally seen this asked in grade 12. Next question. It says calculate the x-intercept. How are we going to calculate the x-intercept? We have to make our y 0. Didn't we do that already? Yes, there. We made our y 0 and we got our x-intercept. So our x-intercept is by 6. And there we answered all the questions for question 2. For question 3, we are going to find the equation of the following function. So when we look at that function, we need to identify it as an hyperbola, and we need to identify the standard form, a over x plus q. You need to know that that is our horizontal asymptote, and you need to know we can't read that a off there. We can't look at the graph and see, oh, okay, a is there. We're going to have to calculate it. But what can we read off the graph? We can read that q value off there because it is where our horizontal asymptote is, which must be there, hey? Right, so our q value is by 2. So we can go plug that in immediately. Y is equal to a over x plus q. Perfect. So in order to find the equation, what do we still need? We're going to have to find that a. And now we can calculate that a by just plugging in a point that is on the graph. So it must be one that we can read off there clearly. So what about that one over there? That point where x is 2 and y is 0. Let's go plug that in there. And that would give us our missing perimeter a. My y is 0, my x is 2, and my q is 2. So we are just confronted with some equations with fractions. I'm going to take that 2 over. It's just manipulating equations. And now, in order to get the a by itself, I am going to multiply this side by 2, because if I do that, those two cancel out, as long as I do it on the other side as well. So then I found my a to be -4. Cretins, does it make sense that my a value is a negative? It definitely does, because we can see that it's in quadrant 2 and quadrant 4. So therefore, the equation of our hyperbola is -4 over x plus 2. And we answered the question. Last question. Write down the domain and the range for the graphs in question 2 and question 3. Okay, so we're going to go back to the graph that we drew, and we're going to go back to the graph that they gave us, and we are going to give the domain and the range. For the domain, we're going to look at the x values, and for the range, we are going to look at the y values. Let's go. Okay, we need to give the domain and range of this, but this is so messy. So I'm just quickly going to create some space. If you were doing it with me, I'm sure that it makes sense to you. But if you would just look at that for the first time, you would think, I don't know what you would think. Let me take away those axes of symmetry and whatever that was. And okay, so I'm just going to go highlight those curves that we actually need to look at. So there is the one curve that we need to look at for the domain and the range. And there is the other one. Okay, now let me actually also delete that. All right, how does it work? For our domain, we're going to position ourselves on the x-axis. And if we go towards the graph and the graph exists there, there's a solution there, it will be part of the domain. So if I go position myself there and I go towards the graph, there's a solution, 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 and it carries on and on and on and on and on, right? So there isn't a restriction towards negative infinity for x. Then there's a solution, there's a solution, there's a solution. But then when I'm at x, that is my vertical asymptote. So x cannot be 0. But if I just go over 0, there would be a solution, 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 solution. If I go towards the graph, solution, 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 the graph exists there. So there's one value that's excluded. X can't be 0. And we spoke about that, hey, because it will make that undefined. So the domain for your hyperbola, x is an element of real numbers, but as long as x is not equal to 0. There's our domain. Let's have a look at our range. Again, let's clean up a bit. All right, for our range, we are going to go position ourselves on the y-axis. If we go towards the graph and a solution exists there, it's part of the range. If I'm there, solution, 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 the arrow goes on and on and on. There will be solutions. There will be solutions. There will be solutions. And then when I get to that point where the asymptote is, there is not going to be a solution. If I just go over it, there will be solutions again, and there, and there, and there. So same as with our domain. Our y is an element of real numbers, but there's one exclusion. Y cannot be whatever the asymptote is, in this case, -1. So whatever your q is, that will be excluded for your range. Okay, domain and range for number 3. The domain, we are going to position ourselves on the x-axis. We are going to go towards the graph. If the solutions exist there, it is part of the domain. There will be solutions, yes, and it will carry on. There will be solutions when we get to 0. It's the asymptote. There will not be a solution. The graph does not exist there. But if I just go over it, there will be solutions again. There will be solutions. So just like with the previous one, my domain is an element of real numbers, just as long as my x is not 0. And that is going to be your domain for an hyperbola. And then for the range, let me clean up. For the range, we are now going to position ourselves on the y-axis. Let's go and do that. If I position myself on the y-axis anywhere, if I position myself there and I go towards the graph, solution, 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 the graph exists there and there. When I get to that point though, of my asymptote, the graph does not exist there. It is my asymptote. But if I just go over it, there will be solutions again and the graph will exist there. So my y will be an element of real numbers as long as my y is not equal to wherever the asymptote is.